problem 58 of Neetcode 150. Construct the binary tree from pre-order and in-order traversal. Okay. I would like to mention that in this video, I am going to show the basic solution, the one with the time complexity of big O of n square. Although there exists an algorithm to solve this in big O of n time complexity, right? This is what they recommend, but it is a bit more complex. So I will focus on finding the solution of this problem first, and maybe later I will do a video for the optimal solution. But for now, this is just going to be the basic solution. So in this problem, we're given the integer array of pre-order and in-order array, and we have to build back a binary tree from these informations. So first of all, let's ensure that we know what we mean by in order and pre-order. So in order traversal, so we are going to start from the most the bottom left element here, 10, and then we are just going to go one more up and add this value up. We want to see if there is a value to the right. Now there is one, so we are going to go check this value. Okay, and then we're going to come back to here. All right. We're going to come back to 34 because there 38 has no childs. So we're going to go back to 39, and at 39 we will do the same thing. We'll see there is another 39, and that 39 has no child itself. So we are going to keep moving to the 47, and notice that in the meanwhile we actually add to our in order array the value 10, 34, 38, 39, and 39 respectively, and then 47. All right. And now when we are at 37, we have to also take the most left value here. So we are going to start with our 59, and we're going to go up to our 79 and back way to our 88. Okay, so this is the logic of an in order. All right. What is good with the in order is that you notice that we went through the entire left array before going to the we went through the entire left branch before going to the right branch. So we know that if we take our 47 here, right, everything to the right is in the right branch, everything to the left is in the left branch. So this is something super interesting to that we're going to use in our problem. All right, now let me erase this and set the tone for the introduction of what is pre-order. All right. So pre-order is going to start with the initial node, and it's going to go as far as possible to the left. So we're going to start with 47. See, we're adding 47 here. And now we're going to go to 39, 34, and 10 until there is no value to the left. And this is where we are going to come back to our 34. And at our 34, we're going to go see if we can go somewhere on the right. Yes, and on that right, can we go any further down? No, so we are going to go back to our 34. Our 34 is going to go back to its 39. 39 is going to go back to its right value. To see if its right value has itself child, it has no child, so it's going to go back to the 39, and then it's actually going to go to once it is at 39, it is going to go back to 59. And I just noticed that I did a light error here. Okay, so thing is that once we actually did the entire left, the entire left, excuse me. All right, so this is not an error because yeah, once we actually go back to 47, once we did the entire left branch, we are going to go to our 79 here, and we will try to go as far as possible to the left. If it is not possible, we will look for the right, but there's nothing to the right, so we're going to go back one, and then we will check here if the 88 exists. If it exists, we will go see if there is a left value. If there is not, is there a right value? No. So we end up having an array where we know for sure that the first number is going to be the root element. Okay, so now we have a couple pieces of information that are quite interesting to solve this problem. All right, so The problem itself is a little bit complicated, so trying to first figure out how to solve it is good, and then we can think of way to optimize the time complexity. So we actually know that 47, or the first element of preorder, is going to be the root element, right? Okay, cool. We know that this is the the first element. Okay, so we know that we can actually access what is on the left and what is on the right of that root, right? So we can go see in the in order array that all the elements to the left of that value 47 will be to the left, and all of the values to the right are actually going to be to the right branch of that 47 node. Okay, so this is cool because we can use recursion, and every time apply the same principle. So for example here, we have 39. So when we go to 39 here, we know that, or we're actually going to reach our first 39 here. When we go to 39 here, and let me use another color to be clear, right? When we use this, when you reach this 39, we know that to the right of that 39, we have another 39, and we know that to the left of that 39, we have a 10, we have a 34, and we have a 38. Okay, this is exactly what's happening. So we are going to use this exact recursion, and let's start coding this slowly, and we're going to come back to this black part again. But for now, let's just set the basis. So first, we want to handle the edge cases where there is no preorder and or no in order. So we're going to say that if there is no preorder or no in order, we want to return none. Okay, it's the first check. All right, and after this, we want to set the root, all right, to the first element of the preorder. Notice that, well, recall that this is actually the root element, right? 47 here is the first element of preorder. So we are going to also create, we're going to create that in the tree node. Okay, and this is where we are going to place that the first value of the tree node is going to be your 37, so the first element. All right, so this is how we are going to create a root. Okay, and now we actually have to find the index of that root number inside the in order. All right, so this is going to be we can call it the middle. So mid, this middle is the value where we are going to know where the, or what the values on the left branch are and what the values on the right branches are. All right, so let's define this as mid and say that this mid is basically, and let me use some Pythonic functions here. So let me call first in order dot index, and we're gonna pass that value at the first index of preorder in. So this is gonna actually find the index of that root value inside the in order array. And after this is where we want to use our recursion call. So we're gonna set the root left and the root right equal to the recursion calls with the parts of the arrays that are pertinent. So we are gonna say root that left and root that right. Okay, and actually what do we want root that left to be is to be the result of the recursive call of that same function build3. And inside the build3 function, we have to pass two elements. First, we have to pass the preorder and also the in order. But actually, the preorder of that left side, like if we take a look at what it should be, well, let's think of it. Okay, that 47 element is at the index. It's at the index 5, right? So what if we go reach the index 5 of the preorder? we are going to reach that 39. So we know that every values up to that index 5 are actually going to be included in the left in the left branch. All right, so this is another y string that we can use with the or what we are given, so the pre-order array. So we know that also all the values after this 39s, so 79, 59, and 88 are going to be on the right side of the initial node. So um, basically pre-order, it's going to start at 1 because we don't want to include the root value itself. And it's going to go up to the mid value plus 1, right? We have to use plus 1 because in Python, the right element is actually the bound, so it is not included. So if we just write mid, we are not going to include the middle in it. Okay, and the in order is basically going to be everything equals, well, everything before that mid value. Okay, so when I say when I use this notation, I'm taking all the values before that mid values. And sorry for the mess we created here with all the colors, but this is how we are going to use a recursive call. So root that array, it's going to be quite similar. So we are going to similarly call again our function, and we're going to pass pre-order and in order. It's just that the pre-order, instead of um, starting from the index after in or at the index 1 and stopping at the middle value, it actually has to start from whatever is after the middle value. So we are going to do exactly this. We're going to say mid plus 1, so whatever the value is up to the n is going to be the pre-order, and the in order, right? In order, if you recall well, it's this function here. So if we still have the root 47, well, the in order that we want to initially send back to the recursive call is actually everything to the right of that root inside the in order. So everything to the right of 47, these three values, this is what we want to first send in the recursive call. All right, so to do so, we are gonna we are gonna say mid plus 1 call. So this is gonna take all the values. All right, and then we can actually return the root. And after all these recursive calls, we will have created a tree node exactly the way they want it to be. Okay, so if I submit this code, if I didn't do any typo, it should work perfectly. Awesome. All right, so I hope you learned from this video. I want to recall that this is not the most optimal solution. This is using a time complexity of big O of n squared. There is also a way to do this in big O of n. So I encourage you to also go seek for this solution if you're interested in it. Otherwise, I'll wish you a good rest of your day, and I'll see you in the next video.